preparation of good geological and geochemical maps, and at the same time how the geochemical data bank or geochemical data set has revealed certain observation which has got very good geochemical implications. So interpretation of the data in this project. So first of all, if you are applying your geostatistical and statistical knowledge, you should be very much confident about what you are doing for. Second aspect is the geological aspect. The science of geology has to be understood thoroughly before going to any interpretation. So with a click of a button, you can produce an excellent map, but how the map is helpful and what messages those maps are bringing out, that has to be understood. Some of the observation I have made, and this is my little bit expertise in the field of geochemical mapping. If you go through a theoretical geochemistry, you have already observed that in geochemistry certain elements are extremely correlatable irrespective of their lithology. Certain elements are concentrated in a typical lithology and then they are correlatable. Now, as for example, zirconium, hafnium, tantalum, niobium, lanthanum, and lanthanides, other yttrium, those are extremely correlatable in nature, irrespective of any lithology. But sometimes what we feel, these are not taking place. In all practical purpose, theoretically it is possible, it is expected, but the expected correlation pattern is not revealed in the geochemical data analysis from the statistical analysis of the data. What does it mean? Now, one very important aspect in here, whenever you are given any task or any FSP task, they are concentrated only within one topographic sheet. And in this topographic sheet, there are diverse lithology. If the lithology, one parameter is constant, means all these expected correlation pattern would be revealed out of it. But it is not happening sometimes. This is because of that mixture of diverse lithology. So if it is extremely erratic or little bit more erratic when the lithology are extremely contrasting, like when in granitic rock and ultramafic rock and basic rocks are in a considerable amount, considerable area and extent is exposed over here. So about 90% of the area is occupied by granitic rock, 10% in other rocks, it will not give that much of effect, and you expect thereon the good correlation pattern, particularly found in the lanthanides and all. Similarly, if the area is exposing ultramafic and mafic rock, other sets of elements like chromium, cobalt, nickel, there the correlation pattern will be extremely good, because ultramafic rocks you get more chromium, cobalt, nickel. If it is your olivine-rich rock, you will get more nickel and cobalt, whereas in case of pyroxene, you will get more chromium and other things. So that things has to be, you have to keep into your mind. Then, first is the relation between your lithology and the elemental distribution. Then comes structure. Within the same lithology, some of the elements are concentrated along a particular structure, and these structures are basically folds. Fold will not give you much of these things. Sometimes it gives thickening of the hinges and other things, but that is rarely happens. It is on the contrary, fold gives much more localization of particular elements along particular, provided the faults are of younger ages. Archean faults have been many a times removed by the ice. They may or may not give, but the younger faults are always very much helpful for giving concentration of particular elements. That has to be this thing. Then the stratigraphic. Some stratigraphic horizon, same rock, similar type of rock, in different stratigraphy may give different concentration pattern. Like your Archean ometides or ultramafics will give different concentrations, elemental distribution and the enrichment, and then younger proterozoics compared to that will give different things. So these are the things. Second aspect is that dispersion pattern. Some of the elements are extremely mobile, other not. I have given some example like your nickel, chromium, cobalt. Then comes lead, then come copper, then zinc. So when you are doing all these things, at the same time from acidic rock, you are having zirconium, thorium, niobium, tantalum, those are things. In acidic rock, again, uranium is extremely dispersible. So what you are doing, if you are expecting a correlation with the lithology, elements which are extremely immobile or less immobile has to be taken into consideration for such type of correlation. Where they are extremely mobile like uranium and other things, you have to be very much careful. So uranium generally in Australian provinces and Western provinces use it. They are dispersed in the stream sediments, flood bank deposits like that. So original it was not there, it has been dispersed. Second, one is this system, and then now come, that is geological aspect. You have to standard geology and present it. But here, the objective is a little bit different. How we have applied your geological GIS tools in interpreting the map. So that they have taught you why geostatistical analysis tools